Okay, welcome back. Chapter 2, I have moved to the conference room at THEC, so let's hope that nobody comes in because I wanted my awesome visual back here. What I want to talk about from Chapter 2 are just two big points, and those are types of variables, which are covered pretty thoroughly in the textbook, and different ways to sample a population that I don't want to get into too much. But for those of you who are going to continue on at ETSU in the EDD program, or an EDD or a PhD elsewhere, this may be relevant to whatever future work you may do in your own research. So let's talk first about different types of variables, which is my handy dandy poster back here. Very, very high budget here, folks, with my poster paper and my markers. So what a variable is, which is outlined in the text, is a characteristic or some kind of element that will vary between people in your sample. So for example, sex is a variable, race is a variable, ACT, GPA, these are big ones that we often use. Whether a student is Pell eligible or not, family income, these are all variables. And if you were thinking about this in terms of a spreadsheet, these would be the columns on the spreadsheet. So each row would be a student, for example, and each column would be a variable. So I don't want to spend a ton of time on this because, like I mentioned in my last video about the parameter versus statistic versus population and sample, some of this is a little bit semantic, but some of this will have implications for methodologies down the line. So if you go beyond this course with your stats coursework, there are particular ways in particular courses actually that are offered in how to analyze categorical variables, for example, rather than quantitative variables as we think of them as being continuous. So this might be more relevant down the line for those of you taking more courses, but I just do want to spend a couple minutes on it today. So when we talk about different types of variables, there are typically two types that we talk about, quantitative and categorical. That's the black line here. Starting with quantitative, now I know that the book mentions interval variables, but it then kind of goes on to mention that typically we think about quantitative variables as continuous. And I would agree with that. I think most often the terminology that I have heard in my coursework and when I've taught stats before has pretty much been continuous or categorical. So thinking about an interval variable, as is described in the book, is something that might be like a scale of 10. Like how much money did you make in an hour without a college degree? $10, $20, $30, whatever. That is an interval variable. But for the most part, when we think about quantitative variables, we think about them continuously from 1 to whatever. So for example, in the book, it mentions that a continuous variable can pretty much go to infinity, right? So the example I will use here is age. Nobody lives to be 500 years old, but age is typically considered a continuous variable. Same thing with adjusted gross income or family income. Nobody other than some like very, very, very rich people who are outliers make like a gajillion dollars a year. But even though there is some sort of stopping point, that's typically considered a continuous variable. So I guess the point of all that is talking about interval variables is not particularly common, but talking about continuous variables, which is basically just numbers that mean numbers. My income last year was $20,000, your income last year was $40,000, and that is a continuous variable in our variable column, right? So the easiest way to say that is just that it's a number that goes from 0 to whatever is a continuous variable, aka a quantitative variable. Categorical variables are different, and it's important to know the distinction between the nominal and the ordinal variables. So a categorical variable is basically not a continuous variable. It's some kind of category, right? You're not going, like the example I just gave with AGI, it would be something more similar to low income all the way to high income, as is mentioned in the book. So a nominal variable, for example, is something that does not have any kind of value inherent in it, or no kind of numeric value. So the example that's given in the book is how do you get to work in the morning? Bus, car, plane, train. That's an example of a nominal variable. Now, sometimes those variables are represented with numbers, like 1 equals train, 2 equals bus. It's still a nominal variable. It doesn't become a continuous variable or a quantitative variable. when it does that. That's really just for the purposes of coding and analysis, but that's a nominal variable. Another example of a nominal variable could be, where did you go to college? ETSU, MTSU, Vanderbilt, Nashville State, Jackson State, whatever. That's another example of a nominal variable. An ordinal variable, on the other hand, is more like a scale. When you think of a Likert scale, and I'll get back to that in a second, when you think of a Likert scale, which is typically 1 through 7, that would be an example of an ordinal variable. And the example in the book is one of, how much do you agree with this statement? Strongly agree, neutral, disagree, strongly disagree. That would be an example of an ordinal type variable. So anything that's a scale like that, it's like a sliding scale, that would be ordinal. Now, mind you, I said Likert. This is a fun University of Michigan fact. Rensis Likert's name is actually Likert. Somehow it became Likert scale when it became more Americanized, but he is a former faculty member, long deceased, of the University of Michigan, and his name is actually Likert. So it's another fun fact for you that it's not actually pronounced Likert scale, it's Likert scale. So spread the word. When people look at you funny, feel free to correct them, because people look at me funny every time. But the point of that is that when thinking about an ordinal set of variables, or an ordinal variable, that would be something like a Likert scale. All of these are very relevant in all types of research. Again, if you do more stats down the line, there are special ways to do probability calculations or to do different kinds of analysis and different kinds of statistics using categorical variables rather than just kind of regular linear regression on a continuous variable. So we will not do too much with the categorical variables other than when we talk about descriptive analysis. But just kind of an FYI for the future. Any kind of regression or linear regression that we're going to do, we're going to think about the continuous variables. But in your future stats life, there might be a lot more application for the categorical variables. Very quickly, talking about randomization and sampling. So generally speaking, we talked in chapter 1 about the need to often use a sample rather than a population. There are a lot of ways and a lot of things you need to consider when you are looking for that sample. So for example, they talk a lot about randomization in the book, and I don't think we really need to get into random number generators or whatever else, but let's say that I have a question about how students perform in Stats 101 freshman year on your campus, and there are 4 sections of Stats 101 that's given in a given semester. So the best way to sample those students would be to pick a random number of them, or randomly pick a number of them from each of those 4 sections, rather than go to the class that meets at 8 o'clock in the morning and sample that whole group. Those students could be very different from those taking the other 3 courses. They could be more motivated, so they're excited to take an 8 a.m. class. They could be adults who have childcare issues in the afternoon when their children come home from school, so they need to be home at a certain time. They could be fundamentally different than their peers in the other classes. So the best way to randomly get a sample would be to randomly choose students from each of those 4 sections rather than just give it to one class and say this is representative of all the students taking Stats 101 on my campus. So something to think about if when you write a dissertation or when you do other stats coursework, or if you ever were to do a survey or do some kind of interviewing, really thinking about who is in your sample and how you select those people into your sample. You can't just pick the people who are around or necessarily the people who are most convenient. Now, there's something called a convenience sample, in which you basically just do that. You take the students, or you take the people who are right near you, and you interview them, you do a focus group with them, whatever it is. But if you can randomize, it's always better to randomize. So one more point about the sampling is that no matter how you sample, and let's say you do it perfectly, it's perfectly random and it's perfectly representative, which it never will be, but good luck. You can get close. There are always going to be biases in whatever research you do. And the 3 examples that were given in the text relate to biases in your sample as well as response bias. So the first example is kind of the one I just gave about the Stats 101 courses. So your sample is just kind of wrong. Or it's not wrong, but it's not really representative. It could be disproportionately one type of student versus another. So that creates some bias in your research that you're doing with that sample. The second type of bias comes from when you're asking students something that they might not want to respond one way or another to, be it via survey or via interview, whatever it is. So very common, these types of questions are about drug use, or about do you smoke, do you drink, how many sexual partners have you had in the past month, whatever it is. If it's kind of an unsavory answer, people aren't going to want to give it. So that's something give you that answer, that is. They'll take your survey, but they're either going to lie or they're just not going to answer the question. So that's something to think about if you ever have research interests that are delicate in some way that people might be sensitive about. You can get some bias in your responses. People say, no, I never smoke. Your entire sample never smokes, ever, or never had alcohol or anything like that. So it's something to be mindful of in terms of how you word your questions and in terms of how you kind of account for that in your analysis. And then the other is a non-response bias. You hear all the time about people who do surveys via mail or surveys via like SurveyMonkey or something online, and they don't get much of a response. And so we'll talk in a couple weeks about power and how much power you need in your analysis in order to really think it's like a valid conclusion that you draw, but you don't often have enough power if nobody's responding to your survey. So quick and dirty, those are kind of easy, common bias issues, and I talked a little bit about the different types of variables, whatever else. So all of this gets much more sophisticated as you go down the line. If you're interested in that, let me know. I'm happy to talk about this like till I'm blue in the face. But I think in terms of the work that we're going to do this summer, this kind of high-level view should definitely be a good start. So I hope this was helpful, and everybody call me, email me, whatever, if it's not helpful, and I will be back with chapter 3, probably not today, probably another day. Okay, bye guys.